So hello, I'm here to talk about JetStream, which is an upcoming technology we have to replace NATS streaming server in future. It's currently a technical preview. We've been talking about it for a few months, and we'll go into a bit more details. Of course, we have a short period of time, 20 minutes, and so I'll focus on some key areas, but we're always happy to take chats afterwards on Slack and so forth. So I work at Synadia. You can find me on Twitter and Pienaar there. I've created various pieces of technology in the space. Korea, I maintain one of the maintainers of NATS streaming server, Surveyor, which we'll talk about a bit later, and JetStream and so forth. So what is JetStream? JetStream is the next generation of our streaming technology. We've previously had a server called NATS streaming server, which is used quite widely, but we've moved on. NATS 2.0 has changed significantly the security model and the deployment model of NATS and brought in multi-tenancy and so forth. And so we had to revisit how we handle streaming in the NATS ecosystem, and JetStream is basically where that's led us to. In the past, we had two separate binaries that was NATS streaming server and NATS. And it was kind of weird and a slight disconnect in how you have to think about these different tools and different messaging topologies. We've made it into a single server binary, so anyone who has NATS will have JetStream, and we've tried to make it less orthogonal to the model of NATS. Streaming capabilities effectively brings at least once delivery model, only to specific subjects, not to the entire server. So when you publish to core NATS, you basically send a message, and if no one's listening, it's gone. At least once means you send a message, the server will hold on to it, and consumers can come back later and receive those messages. And so we will support both those models in the core single NATS binary that we're going to ship to everyone. We looked at how we did NATS streaming server. We had to maintain different clients, and people had to maintain slightly different programming models, and there was various restrictions on how you had to interact with it, and we couldn't really make use of the wide 30, 40 plus languages that we support today because we had to write additional clients for streaming server. In JetStream, you use any standard NATS client that you have now, any of the supported languages can interact with JetStream. You don't have to learn a whole bunch of new things. It's quite a comfortable fit within the NATS ecosystem. We support all of the routing and security features and multi-tenancy and multi-accounts and all this kind of stuff that NATS 2 has delivered. And so multi-tenancy is a huge point. If you offer middleware as a service within your company, or if you use a commercial service, you can have a single set of compute services that provide completely isolated data stores, streaming servers, etc., completely isolated subject namespaces on top of NATS, and expose those completely isolated, but with the same multi-tenancy features in NATS 2. You can share data only when required, and both parties agree. JetStream plugs into that completely and supports all of those models. We support a push-based model where you get the messages as quick as they're available, or a pull-based model, which is really good for scaling out horizontally scalable consumers. It's quite a comfortable way of working with jobs coming off a work queue kind of thing. We support something that's a little bit more like a work queue, where a message will be removed as soon as all parties who had interest in that message is acknowledged that they're done with it. And so there's a number of different ways of consuming and producing messages into the system, but all over core NATS. The administration of the system is an API. It's almost a lot like a web API. There's normal CRUD operations: create, remove, update, delete, etc. But you access that API via the NATS network. So you would just publish a JSON message onto a well-known subject, and that's how you access the API. So again, we don't need to necessarily write a lot of custom tooling and custom clients and so forth. And any library that you already have that can communicate with NATS will be able to administer JetStream. Unfortunately, or not necessarily unfortunately, but of course, the JSON structures have structure to them, and you have to understand what they are, and we will provide helpers for creating those, but it's just JSON messages that quite easy to do. We have a new CLI administration interface where you can create your streams and so forth from the command line, either interactively or as an API. And we also support Terraform, and we plan to support more systems in the future. Currently, JetStream is in a technical preview. If you click on the link there, you will see details about how to get going with it. We are not shipping it as part of the released version of NATS server yet. So there's a Docker container and instructions for building it yourself if you wish, and how to get going with the tool. I'll mention a little bit in the next coming up slides on where we're at for putting that into core NATS streaming server, into NATS server. So in the documentation, we have this diagram here that basically describes a microservices architecture built on top of JetStream. It doesn't necessarily demonstrate all of the capabilities of JetStream, but it's a good indication and a good thing to have a quick chat around, so you can get an idea of what it's about. I will just turn on the pointer here. So on the left-hand side, we see messages coming in and out of a stream. These messages are standard NATS messages. They are published to normal NATS objects. As you already, if you use NATS, you will know how they work. You can either just publish them, in which case they're unacknowledged. The stream will take them if it can. But you can also use our request API, where you send a message into JetStream, and it will acknowledge to you that it's received it. And it will tell you some metadata about the message, things like a sequence number and so forth. But these are standard NATS messages on standard NATS objects. We then have the stream. Here, the stream has a name called orders. And you can see the stream listens on subjects, and here we're listening on a wildcard of subjects. And this is a key difference from NATS streaming server to JetStream. We support wildcards. So in the first section you saw, we deliver messages orders.received, orders are processed, orders are completed, and they will all end up within one stream storage based on the wildcard subject that receives them. A key capability of a stream that to me at least, and I don't know if this is an official definition of what a stream is, but this is how I think about them, is that the data is stored within basically a log. It's a series of timestamped events, and you can have multiple people consume those messages, or multiple services consume those messages, and they can each have a unique view over that data. They can be in different places within the data. They can have different acknowledgement states of the data. One can push it, one can pull it, one can want acknowledgements, one doesn't want acknowledgements, and they can use different things at different times using the data that's in the stream. And so we have a thing called the consumer that describes how a set of related services wish to consume data that's held in the stream. So earlier you saw we have a wildcard of subjects that's within the stream. When we create a consumer, we call it new. We want to consume messages from the stream orders. We want to pull the messages, meaning one at a time as we're ready. And we want to filter the messages that's in the stream based on the subject. So we make sure that we only receive a subset of the messages. This way, one store can store all of the related messages related to your orders, but a individual microservice only gets the messages that it actually cares for. And doesn't have to programmatically go and filter things out. Pool-based means if I am ready for a message, I ask a server to send me the next message. There's some ways to optimize that. It works a bit like a HTTP long poll. So if I can say to it, look, send me the messages when it comes, so even if there's no message for an hour, when it eventually comes, I'll get it. There's ways to optimize that as well, which we won't go into too much. But it's a pool-based thing, and this is really nice because you can scale up horizontally by having 20 or 30 or 40 of these microservices handling incoming orders, and they will just pull it as they're ready. In other words, we don't do the round robin, or we don't have to do the random selection or the least weighted traffic, etc. The microservice decides it's ready to submit to receive the next order, and it pulls it and gets it. When it processes this message, if it completes, it can acknowledge that back to JetStream saying, look, I'm done with this piece of work, don't send it again to any worker. Or you can say things like, I'm not going to handle work, give it to someone else. Or you can say, it's taking me a bit long to handle one, give me another half a minute to handle this message. So we have a number of models there for how to communicate the success or the life cycle of that particular message. When it's done, it publishes a normal NATS message again to the next subject, which again goes into the stream and flows into the NATS microservice. This one's very much the same, so I'm not going to go into details there. Down the bottom, maybe we have a operator, a human being who wants to just do a tail minus F style look over the messages, or some kind of tool who wants to consume all of the message related to orders into it for ordering purposes, or any kind of operational tooling that you might have. Here we use a push model, so the messages comes as fast as they're available. It's not necessarily important though if I can't keep up. In other words, I also disable acknowledgements, so this is literally just a tail minus F, let them scroll over. Dale was talking a little bit about observability in NATS, and we really care for that topic. And in JetStream, the thing that matters is between the consumer and the microservice is how many times does the microservice fail to handle that message. In other words, how many times has this message had to be redelivered for processing, perhaps because the microservice crashed. And the other thing that matters is how long did it take for that message to be processed. If you're handling Valentine's Day, you would expect process time to be significantly up versus middle of the previous night. And so we allow sampling of the timestamps that those things take. So it will emit into Surveyor, which we'll talk a little bit about later, or into Prometheus, advisory events that says a message took 10 milliseconds to process, and we had to try 4 times to get that message delivered and processed correctly. And so you'll be able to receive those, suck them into your administration tools, and make operational dashboards, graphs, alerting, etc., about the health of your microservices without having to implement any additional logic in those individual microservices to enable that. So that's basically a quick tour around, around how a stream-oriented microservices might look. There's of course many other use cases for streams in terms of processing streams, combining streams, doing on-the-fly computation, and so forth. I think those cases are fairly well known, but the diagram here describes most of the features that we have within JetStream and the approaches that we want to support. Now, as part of the creation of JetStream, we also created a new NATS, just called NATS CLI tool. And if you've used NATS box and so forth before, you will know that we have tools like NATS pub and NATS sub and NATS reg and so forth. And we've had a few of them in the GitHub repositories, and we have another one in NATS box. They're all slightly different. So I've gone around and I found all of these little utilities that we had lying about, and I pulled them all into one standard CLI that supports benchmarkings, all of the kinds of pubs and subs and requests that you want to do, supports acknowledgement, it supports viewing various events and lifecycle things coming out of NATS. It is the same utility that you use to configure the entire JetStream system. It supports all of these JSON structures to the APIs. It can view audit logs for you, all these various things. Its abilities are all done via a Go library. So if you're a Go programmer, you will be able to build your own tooling that matches these administrative abilities, maybe a web interface or something along these lines. And this is also still in technical preview and delivered as part of the JetStream Tech Preview at the link that you can see there. Now we mentioned management a little bit. You have a few options. You can either have your microservice start up and detect that it has JetStream and detect that the streams aren't there yet, and so it will create it on on demand based on what its internal knowledge is, or you can pre-create them. And if you might want to pre-create them during your CI/CD system so that you can stand up a JetStream just for the purpose of that single CI run. And there you can use the CLI It has a interactive mode where it will ask you questions, explain to you the things that you have to enter, but it also has an unattended mode where you pass all of the information on the CLI. So that, good for CI, and CD. We have a Terraform provider. So if you're standing up your infrastructure using Terraform, perhaps you run your NATS servers in Kubernetes, or you use a service like our NGS, or you're a team who accesses a remote JetStream that another team may provide. The Terraform provider can configure and provision JetStream streams and consumers in any JetStream, regardless of where it runs. And I mentioned the Go library, that's all there. We have a number of events, so we have a full audit log of all of the API interactions, so you'll be able to see the user, every request they make, create a stream, edit the stream, change the configuration for a stream, who's trying to consume what, security-wise, all of the APIs fit perfectly well into the normal NATS authorization and auditing kind of stuff. And so you will be able to control that user A is allowed to create streams, while user B is only allowed to see when streams are there, while another user is allowed to create and delete and so forth. All of these things are published via events, and we have a couple of events that implement something equivalent to a dead letter queue. So you can configure that a message is only going to be tried 10 times, perhaps as crashing microservices. And then we will publish an event saying that message is bad, and you can get hold of the content. So there's a rich management ecosystem. We are constantly looking to improve that. I mentioned we support Terraform today. If there's significant demand for other tools like Puppet or Chef or Ansible or whatever, we can look at implementing those. But we're kind of going for the cloud native options first. We may make a CRD for Kubernetes, which I'm quite keen to do. I think that'll be quite a good fit there as well. The roadmap for JetStream, and we're getting towards the end of the talk. Today, as I said, we're in a technical preview where it's only a single server and it's not part of the NATS binary yet, the officially shipped NATS binary. That will change by release 2.2.0 of NATS server. You will get JetStream delivered to you. It will still be a single server limitation. It'll be behind a feature flag, but it will be there for anyone who wants to play with it. Anyone who downloads NATS will have it. We're hard at work on clustering so that you can have a really distributed system that reliably stores your messages. You'll be able to say a single particular stream should be distributed across 3 physical servers or VMs or storage entities or whatever. We hope, and this is not carved in stone, but we hope to deliver that around Q3 or before. We want to give people better insight into the running the insight into the runnings of a NAT server, better than tel -f the log files. So we want to create APIs and event streams and audit logs that shows you all various things that happens within the server. So if JetStream were, for instance, unable to write messages into its file server, we don't want only the people who have access to the log file to be able to be aware of that. We want the administrators of any system that uses JetStream have access to that. We will support more helpful libraries with other languages, the main languages, of course, Java, .NET, and so forth. Documentation right now is in a big single markdown file. We will move that to the official documentation site as we move towards GA. We will integrate it with NAT Surveyor, which we will talk a little bit in 2 or 3 talks from now. And something that's close to my heart is integration of the third-party ecosystems. I recently integrated into Telegraph, cloud events. We're busy integrating with OpenFast. I am working on something with Fluentd, and we're happy to get community feedback on where you want to see integrations and what you want to have see support JetStream, so that we can make this very widely supported system and widely used. While we hope to support third-party streaming systems, we want to be able to deliver a WebAssembly binary into the NAT server signed by your JWT, so you can control the access rights of that WebAssembly binary, and so that it basically executes within the stream of data, and you can do filters and dedupes and all these kind of things that you can write in any language that compiles WebAssembly, which is now quite a long list. We have some more stuff planned, but really this is already quite an ambitious list. And so we will see how we get on, but we're heavily focused on JetStream at the moment, and we're very happy with what's coming up. So what does that mean for streaming server? Streaming server is, we recognize as a production level supported platform. There's 150 million Docker pools of streaming server. We will continue to support it as a production platform until mid-2022. Bug fix, security fixes, etc. until 2022. We don't anticipate major new feature development. And I, for instance, don't support it within the new NATS CLI, in recognition of the status of it. But we will provide migration guides. We're available for consultation around, migrating to JetStream. And we may provide a data migration tool, or at least something that can help. This is a bit up in the air at the moment, but we of course want to try what we can. And that's about it for me. So we can take QAs, and I think there's been a number of questions asked already. But if Derek wants to jump on, you're welcome to do that as well.
All right, thank you. I appreciate it. And what we've done, and I would encourage everyone who wants to play around with this, please do. We have a separate Slack channel for it. We've gotten some amazing feedback and insight into how the ecosystem and NATS users would want to use this. And RI's been amazingly attentive to all of the folks in that channel. So if you want to check it out, GitHub, nats.io/JetStream, and jump on that Slack channel. We really, really want feedback. That's why we released it earlier as kind of a tech preview. As we're still kind of looking at finalizing and coding out the clustering design, which has been finalized from a design standpoint. We wanted to get feedback for people interacting with the system, telling us what they like, telling us what they think could have been done better. So again, if you have cycles and you're looking at this as part of your architecture in the future, please spend some time playing with it, and we're glad to help. So thank you.